Welcome to this explainer. We're diving straight into something I find absolutely fascinating today. We are going to decode the massive energy footprint of the chemical manufacturing industry using the SASB chemical standard. So if you've ever wanted to understand the invisible forces driving our physical economy, you are in exactly the right place. Let's get started.
I want to kick things off by throwing a number out there to set the stage. 70,000. The chemical industry takes raw organic and inorganic feedstocks and transforms them into over 70,000 diverse products. We are talking about literally everything from the agricultural fertilizers that grow our food to the specialty resins and industrial gases that build our homes and our cars. The sheer scale of this output is just staggering. Which really begs a critical question. What exactly powers the building blocks of the modern world? Think about the colossal energy appetite required to run the massive processing units, the heavy machinery, and those immense distillation columns that physically forge all 70,000 of these products. It doesn't just happen on its own, right? It requires a monumental, continuous injection of raw power.
Section 1. The SASB Chemical Scorecard.
To make sense of how this industry manages such a massive operational load, we turn to the SASB chemical standard, specifically the RTCH framework. You can think of this standard as kind of the ultimate scorecard for measuring operational risk and sustainability performance. It tracks the broad impacts of chemical production across the board: greenhouse gas emissions, water management, hazardous waste, workforce health and safety, and even community relations. It's incredibly comprehensive. But today, we're going to aggressively zoom in on just one specific area.
What's really interesting here is how SASB takes those massive, sweeping categories and breaks them down into precise, quantitative metrics. They don't just ask companies to talk generally about being green. They demand specific units of measure: metric tons, percentages, incident rates. Alongside rigorous discussion and analysis, it essentially brings hard math to sustainability.
Section 2. Powering the reaction.
This brings us sharply to the real core of this explainer: energy management. How a company sources, uses, and tracks its energy isn't just an environmental issue. It is the fundamental heartbeat of its manufacturing capability. Picture a massive, on-site cogeneration power plant sitting right next to towering distillation columns, and you'll start to grasp the scale we're talking about. Under SASB metric RTCH 130A.1, the standard requires entities to disclose the absolute total amount of energy they consume measured in gigajoules. This is the ultimate baseline, because before you can optimize anything, you have to know exactly how much raw power is flowing into your facilities.
But hey, it's not just about the total amount, it's all about the mix. Imagine a power gauge shifting in real time. SSB requires chemical plants to break down their energy inputs. They've got to track the percentage of energy coming from traditional fossil fuels like natural gas and natural gas liquids versus the percentage drawn from grid electricity, and critically, the percentage of renewable and self-generated energy like wind or solar installations.
Section 3. Sourcing. Cost versus clean.
Let's look at how this builds into the push and pull decisions executives have to face every single day. Since energy purchases make up a massive share of production costs in the chemical industry, deciding where that power comes from is incredibly high stakes. We see a very pragmatic trade-off at play. On one side, we have grid reliability and cost. Manufacturers absolutely need uninterrupted, cost-effective power to keep production lines running profitably. On the other side, we have clean sourcing and regulatory compliance. Shifting to renewables or cleaner fuels is becoming essential to meet increasingly stringent emissions regulations and carbon taxes. It is a constant, delicate balancing act.
And the ripple effects of these sourcing decisions are profound. As outlined by SASB, your energy mix directly dictates your overall cost of production and the reliability of your supply chain. But it also impacts your associated water use, because power generation often requires massive cooling. It impacts your total air emissions profile, and ultimately your exposure to regulatory risk over time.
Section 4. Principle 6. Energy efficiency.
Okay, so if sourcing is the input challenge, how do we address the consumption challenge? Well, we shift our focus to the factory floor itself. This is the operational cure to the energy problem: energy efficiency. It's not just about buying cleaner power, it's about needing less power to begin with. SASB specifically highlights the implementation of Principle 6, designed for energy efficiency. This comes straight from the renowned 12 Principles of Green Chemistry. The definition is simple but so powerful. It's all about minimizing the energy requirements of chemical processes to simultaneously reduce environmental and economic impacts. It's basically the ultimate win-win scenario. Let's ground these accounting standards in physical reality. How do plants actually slash their energy appetite? Well, SASB outlined some very tangible steps. Step 1. Conducting reactions at ambient temperature and pressure, which completely removes the need for massive heaters or compressors. Step 2. Reducing the need for energy-heavy distillation and drying. Step 3. Simply recovering excess waste steam and heat to generate power elsewhere in the plant. And Step 4. Improving catalytic processes to make those chemical reactions happen much more easily.
And SASB doesn't just want companies resting on their laurels here. The standard asks entities to discuss their efforts to actively advance the industry. This means detailing their mix of everyday, incremental improvements versus actually deploying emerging technologies or developing true game changers. This lines up perfectly with the International Council of Chemical Associations' technology roadmap. They really want to see a clear path to the future.
Section 5. The bottom line impact. So the crucial point is this. We have to zoom back out and connect these micro-efficiencies on the factory floor to the macro financial picture. Why does Wall Street care about ambient temperature reactions and steam recovery? Because shifting energy inputs and implementing green chemistry isn't just a PR exercise to appease regulators, it fundamentally transforms the balance sheet. High energy efficiency directly translates to improved operating margins. Utilizing alternative fuels fundamentally reduces your regulatory risk. And those process advances, they guarantee lower long-term production costs. Sustainability data here is directly correlated with financial resilience.
Which leaves us with this final, vital question to ponder. Is an energy strategy just a compliance cost? Just a box to check for regulators? Or, when viewed through the rigorous lens of the SASB standard, is it actually a blueprint for a massive competitive advantage? The data strongly suggests the latter. Thank you so much for joining me for this explainer. Keep asking the hard questions, and I'll see you next time.